Exercise 8, Conditional Distributions Considering Two States. At this point, the commuter becomes more sophisticated in his analysis and proposes that driving times may be rather different under varying weather conditions. Consider two states of nature, normal and abnormal states. Under normal conditions, commuting times are the same as exercise 1, most likely time is 60 minutes, the minimum driving time is 50 minutes and maximum driving time would be 130 minutes. However, under abnormal conditions, snow, for example, commuting times have a minimum of 75 minutes, the most likely is 100 minutes, and the maximum can reach 240 minutes. Abnormal conditions may arise some 20 days a year. 1. A good hint to solve this problem lies in using the Bernoulli distribution that allows for binary choices, zeros and ones, based on a certain probability, p, value. On cell C55 insert the following function to calculate the probability of abnormal weather conditions based on the fact that they happen 20 out of 365 days. This is the probability of an abnormal state of nature. 2. On cell B55 insert the probability of a normal state of nature as its complement, equals 1 minus C55. 3. The probabilistic definition of the state of nature comes in cell C56 with the function, equals risk Bernoulli C55. The chart for this cell looks like this. This distribution means that during a simulation, with enough iterations being run, approximately 5.5% of the outcomes will generate a 1, whereas 94.5% of the iterations will generate a 0. 4. Next, on cell C50, insert the following conditional function. Equals if C56 equals 0. Risk PERT B52, B53, B54. Risk PERT C52, C53, C54. This formula will generate either one of two PERTs contingent on the probabilistic value of the Bernoulli outcome, either a 0 or a 1. In other words, in approximately 95% of the probabilistic cases hinged on the Bernoulli distribution it will generate a PERT under normal conditions, whereas on 5% of the cases it will generate the other PERT distribution under abnormal conditions. 5. This cell on C50 needs to be declared an output. Therefore, click on the @risk set output button to declare the cell as an output. The following suggested name will appear on the name definition window. Get rid of all the text after the slash to only leave the text name, conditional distribution with two states. After clicking OK here, the cell will now be declared an output and the function will look like this. Equals risk output conditional distribution with two states, plus if C56 equals 0, risk PERT B52, B53, B54. Risk PERT C52, C53, C54. Now run a simulation with 10,000 iterations. If you have your demo mode off, this will run very fast. However, if you run your simulation with demo mode on, you will see the updating of the simulation as much as 10,000 times on top of Excel and your chart being also updated 10,000 times. By clicking on either one of the first three icons on the simulation progress window, the user is able to toggle on and off the display of updating a summary window, the Excel spreadsheet model and the output chart being updated. Leaving these options on can be very demonstrative for users who want to understand the nature of the Monte Carlo simulation process. However, this demo mode on is significantly slower than running your simulation with both options, updating Excel and updating the output chart, off. Both options can be turned on and off any number of times during the simulation run. Do notice also that the forecast calculated runtime and iterations per second calculations change under different settings for both options. On the other hand, the choice on 10,000 iterations is just a recommendation. Any number of iterations can be defined from 1 up to 32 million. In general, the larger the number of iterations the better the precision or convergence of the results, but also the longer time it takes the simulation to run. Achieving convergence or precision on your model becomes an ever-increasing demanding task as such convergence achievement behaves decreasingly on a nonlinear fashion. Observe the extremely long tail that is generated on this synthesized integrated distribution. A single PERT by itself would never be flexible enough to generate such a long right tail. 6. You can stop the exercise here, having generated a simulated function. However, it is always possible for @risk to fit the 10,000 iterations and propose a fitted theoretical distribution that integrates the two PERTs being pivoted with the Bernoulli. Use the following icon on the output window to fit the dataset. 7. A suggested gamma distribution will be the best fitted distribution according to the AIC. We now write this cell back in cell C57. In other words, if you were to use this distribution function for another model that synthesizes the two possible states of nature, you would not require these three used distributions, the Bernoulli plus the two Perts. One single synthesized gamma distribution could do the job for the user.